In this video, let's explore C++ custom exceptions. We will learn how to create our own exception classes for handling specific errors in our programs. Custom exceptions provide a more descriptive and manageable way to deal with errors compared to standard exceptions. Let's discuss why you should consider using custom exceptions in C++. Standard exceptions, while useful, have limitations. They often provide generic error messages and lack specific context information. They don't provide domain-specific details, and it becomes difficult to handle specific error cases. Custom exceptions offer several benefits. They allow for descriptive error messages that clearly explain the problem. They enable application-specific error types. You can include additional error context or data within the exception object. This leads to improved and more precise error handling logic. Let's see how to create a basic custom exception in C++. Custom exceptions typically inherit from the standard exception class, or one of its derived classes. This ensures compatibility with C++'s exception handling mechanism. Here is an example showing a basic implementation of a custom exception class named FileNotFoundException. It inherits from the standard exception class. The constructor takes a file name as an argument and constructs an error message. The what method is overridden to return the custom error message. It also has a private member to store the error message. Now let's look at how to use custom exceptions in your code. Here's an example. We define a function named readFile that takes a file name as input. Inside the function, we attempt to open the specified file. If the file cannot be opened, we throw our custom FileNotFoundException, passing the file name to the exceptions constructor. In the main function, we wrap the call to the readFile function in a try block. If a FileNotFoundException is thrown, the corresponding catch block will handle it. Inside the catch block, we print an error message to the standard error stream using the what method to retrieve the descriptive error message, and then return 1. Let's explore how to create an exception hierarchy. Creating a hierarchy of exception classes can help organize and categorize errors in a more structured way. You can create a base application exception class, and then derive specific exception types from it. This approach allows you to group related exceptions together, and enables catching exceptions by category. Here's an example of a base exception class called Application Exception that inherits from Standard Exception. The derived classes will inherit from this class. Building upon the exception hierarchy, let's examine how to create specialized exception types. Here are a couple of derived classes, File Exception and FileNotFoundException. The File Exception class inherits from Application Exception and serves as a base for file-related exceptions. The FileNotFoundException class inherits from File Exception and represents the specific case where a file is not found. It includes a method to retrieve the file name that caused the exception. Now let's delve into advanced exception handling techniques. When dealing with an exception hierarchy, you can catch exceptions at different levels of specificity. Here's an example showing how to catch exceptions within a hierarchy. We have a try block that calls a function that might throw exceptions. We have multiple catch blocks to handle exceptions. The first catch block specifically catches FileNotFoundException. The second catch block catches File Exception, which will handle any file-related exceptions not specifically caught by the first block. The third catch block catches Application Exception, which will handle any application exceptions not caught by the previous blocks. Here are some best practices for working with exceptions. Always order your catch blocks from the most specific to the most general. Include context information in your exceptions to aid in debugging. Use exception hierarchies to simplify error handling and make it more organized. Consider the performance implications of throwing and catching exceptions, as it can be relatively expensive. And finally, document the exception behavior of your functions and classes to help other developers understand how to use your code safely. Let's quickly summarize what we've covered. Key concepts include inheriting from the standard exception class, overriding the what method to provide custom error messages, creating exception hierarchies to categorize errors, adding context-specific data to exceptions, and catching exceptions by category for flexible error handling. The benefits of using custom exceptions are improved error diagnostics, domain-specific error handling, better code organization, more maintainable error logic, and enhanced application robustness. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.